Hi, good morning. I will try to be short because we are running out of time, and I will talk about global coastal low-level jets and the specific case of the Iberian coastal low-level jet. If we look at the global winds at the surface for boreal summer and austral summer, we can identify some high values of wind speed in some regions in the northern hemisphere over Canaries and California, and in the austral summer over the Humboldt Current, the Benguela, and Western Australia. But if we go up, we see that these higher values are even more conspicuous. These are known as coastal low-level jets, and they are driven by the pressure gradient over between the land and the ocean, and these are quite important for the moisture transport over land from the ocean. They occur in the known eastern boundary current systems, and they play an important role for the regional climate of these regions. These regions are also known as the coastal upwelling systems, and of course they are the most biological productive regions over the ocean. The regional climate in this region is very dependent on the atmosphere, land, and ocean feedbacks, and the mechanisms, the feedback mechanisms that are interplaying in these regions are of course the coastal low-level jets, upwelling, the marine PBL clouds, the high subsidence, and of course the gradients of temperature and moisture. To simplify, we have here the main ingredients to the establishment of these longshore coastal jets, and of course we have in the boreal summer the highs, the anticyclones, the semi-permanent over the Pacific and the Atlantic, that they are the main cyanotic ingredients to the longshore coast over California and Iberian Canaries, and the same appears in the austral summer in the southern hemisphere. These longshore jets, they enhance the upwelling, bringing cold water to the surface that enhance the gradient over between land and ocean, and that gives even more strength to the circulation, creating a thermal wind within the mixed layer, the maritime mixed layer. In some regions, the coastal topography is mechanically forces also these coastal low-level jets, for instance, in California, where the topography is even higher than the maritime boundary layer. Why in 1988, only taking into account these kind of mechanisms, he guessed, in some way, he said that the most probable areas of occurrence of these jets would be these ones, and we see here the Canaries, the Benguela, Humboldt, California, and Western Australia, and of course also the Oman case that is a particular case. A bit later, in the Portuguese and Swedish collaboration, Rania in 2013 developed the first algorithm in inspecting wind profiles and temperature profiles to automatically detect the presence of a coastal low-level jet. And this is quite a simple criteria. The jet maximum has to be in the first kilometer. The wind speed at the jet maximum has to be 20% higher than the surface wind speed, and the jet maximum has to occur within the mixed boundary layer and the temperature inversion. Of course, we need model levels to assess the presence of the coastal low-level jet, and this is the biggest hurdle to use SMIP5 models and CORDEX information. So we unfortunately only rely on our own simulations that we did in Lisbon. So, for instance, with this criteria, Rania performed the first global climatology of the presence of these coastal low-level jets, and according to the study of 88, he identified the frequency of occurrence of these jets in the areas that I referred before, and we have frequency of occurrence of 30% in most of the areas, with of course different seasonal variability according with the different regions. I will not give so much details, but here we apply the same criteria to our ICRC runs. We run 2 members of ICRC in Lisbon, and for present climate we see that in the boreal summer and in austral summer, or summer and winter, we can identify the low-level jets over Oman, over Canaries, Iberia, California, and in the southern hemisphere of Benguela, here in Chile and Western Australia. ICRC is known because it has a warm bias over the southern hemisphere, over the southern oceans. So we see that the frequency of occurrence that ICRC gives are quite low when compared with the air entering. Also, we have to keep in mind that we have a coarser resolution, and this kind of mechanism, this kind of alongshore coastal jets, they need higher resolution. So this gives us an idea that what will be the evolution for future climate, but we have to see it carefully. For future climate, what we see is that we have a general small increase of the frequency of occurrence of these global coastal level jets, but over the Iberian, over Oman, this increase is much higher, like 10%. So it's if we compare with the present climate frequency of occurrence over Iberia, that is like 20%. We have a big increase for Iberia, and that's why we try to put more effort on studying the Iberian cases with higher resolution. Here I show some results of the CORDEX simulation that we did at 50 kilometers. It's still coarse resolution, but in spite of that we have some gains already. And here you can see the Iberian coastal level jet with frequency of occurrence around 20% that are related with the most conspicuous capes over the Western Iberia, of course, because we started to solve a bit the Iberian coast. We can see here that the jet occurs around, the maximum frequency of occurrence is at 400 meters, and with speed mode is at 15 meters per second. Okay. For future climate, according to RCP 8.5, what we see here is that we have a big increase of the frequency of occurrence, and this increase is mostly in the northwest, but in the full coast we have increases of 10%, as a bit in line with ICRC, but in the northwest of Iberia this increase is over 16%. We have a tendency, we can spot some tendency of the model to go a bit up. The jet goes a bit up in future climate and for higher speeds, wind speeds, but I wouldn't say that that's so relevant at 50 kilometers. And why we see this increase, we can see here the anomalies of mean sea level pressure, and we see that we have more low thermal overland, and we have the extension of the anticyclone to the northwest of Iberia is increasing, and its intensity. But we need more resolution. We couldn't do the 12 kilometer resolution of CORDEX domain, so we focus our attention over Iberia for, I think, quite understandable reasons. So we performed a simulation with 27 nested, 9 kilometers nested in the 27 kilometer resolution simulation. And we did the same kind of resolutions, hindcast, historical, and RCP 8.5 future simulation. And here we have the results of the frequency of occurrence of the jet for the 9 kilometers for the hindcast simulation. And we see that this jet doesn't occur only in summer, but also in present climate we have some occurrences of 10% around in the intermediate seasons, and around 30% one in each 3 days we have that jets over the Portuguese coast, and of course the higher frequency of occurrence values, they occur because of the expansion funds down in the caves. Oh, this is strange. No. It changed. It was a nice cross-section of the jet, to see the jet. It's unfortunate that we cannot see it, but let's keep going. It's coffee breaking calling. Here we have the future climate signal, and we see the anomalies of this frequency of occurrence, and we see again a consistent signal of for the intermediate seasons we have some increases around 5% of the occurrence, and around 20% in the northwest of Iberia. Looking to the distribution, not only to mean values or the frequencies of occurrence, we have here the box plots of a full area of the Western Iberia, and the north box and the south box, to see how spatial, how there is this gap between north and south. And we see here that for the full, I'm only focusing on summer now, but in the intermediate season we see a bit the same, but we see here the frequency of occurrence are increasing for the full area. This increase is much higher for the north box than for the south box. In concerning the wind speeds, we see some increases in the north, but a small decrease in the south. I didn't mention, but all these simulations, they were validated for the ICRC simulations. They were validated against the local radio zones regarding the profiles and the sea wind fields. Okay, so I'm a bit fed up of seeing a lot of evaluations, so I didn't put it here. But the 50 kilometers resolution, they were also evaluated. They are quite in good agreement for the Western Iberia, and of course the 9 kilometers adds a lot of value to this wind representation at the surface and regarding the radio zones. So as a summary, we really see this increase of the Iberian coastal low-level jets that we can apply to the other Northern Hemisphere jets. This is in agreement with other studies that they focus more in the upwelling, and like one in 2015, he has the same kind of result, that he has an increasing of upwelling and of the wind at higher latitudes in the eastern boundary currents. Of course, high resolution matters to represent these kind of features, and of course we would like very much to extend this kind of work for multimodal ensembles, because we want to study other regions, and of course to assess the associated uncertainty of these kind of things. Thank you.
We're running late, but one quick question. Yes, Daniela?
So this was very nice, but I did not get the reasoning behind why. So what's the physical reasoning why you have an increase in the future?
That's.
So that's I mean.
Yes. I will.
The point is actually the positioning of the winds offshore.
Mm-hmm.
So evaluation of the wind fields of the models show that there is a displacement of 1 or 2 grid cells towards
Offshore
instead of coast. So the distance from the coast. Have you looked into this? And I mean, it's a bit difficult to validate, but I think it's pretty important for all coastal processes. Also, I mean, we saw a nice talk about the Mediterranean circulation, but we know nothing about the coast, and we haven't heard about what's happening around the coast. So I think. So can you say something if you looked into that?
Yes, I will. So the first question is about why it's increasing, the low-level jets, the main reasons, and the second question is about the validation problems over the coast, offshore, yes, of the displacement. So regarding the simple explanation, and there is a plot in the paper that I had that referred. There is an increasing of the thermal contrast between the ocean and land. So what happens is that with this higher pressure gradient, we are enhancing the pressure, the along-shore coastal over Iberia. This is the local reason, but also the anticyclone, the high pressure of a source, is going further north, and it's more persistent in the north, and the low thermal is also more persistent. So we are also enhancing this pressure gradient in the synoptical view. Okay. Talking about the validation, it's very problematic to validate these kind of things, and I'm not. It's really because sea wind or quicksat is very bad over the coasts. So we do it, but we know that the quality of this sea wind data over in the region that we are interested is very bad. But we also validate with buoys for the Iberian case. So we don't have a lot of buoys. There is a scarcity of data, of course, but we have 5 buoys over the western Iberian coast. And the results of the 9 kilometers is much, much better than the easier ones. Okay?